So thank you all for joining us tonight. I am Sarah Frederick. I am the EcoVenture Coordinator for Rangeley Lakes Heritage Trust, where we conserve land, water, and public access for the Rangeley Lakes region. This evening's program is part of our Dark Skies events for 2023. Hopefully we'll have good weather. We've got 2 more coming up this year in August and September. Then we'll definitely have more night skies tours again next year in 2024. And we'll probably also do some celebration for International Dark Skies Week again. So tonight is sponsored by Dark Skies Rangeley, which is a community-led effort to conserve dark skies over the Rangeley region. So with that, I'm going to introduce John Meter of Northern Stars Planetarium.
Great. Thank you, Sarah. It's a pleasure to be here. Not exactly where I wanted to be because we were supposed to be on Quill Hill this evening, looking over the Rangeley Lakes and looking at the stars. But the weather doesn't always cooperate, as we are all well aware, especially this summer for some reason. So we're going to go virtual this evening and take a look at what we would have seen if we'd been outside this evening, and what you might see if you should get outside tomorrow night or Sunday night, because I hear that it's going to get better. This cloudiness and showers is supposed to last into tomorrow, but then Sunday, Monday, Tuesday, first next week is supposed to be very nice. So other than the position of the moon, which will change, pretty much what I show you here, you should be able to see if you get outside some night soon and take a look at the beautiful skies over the Rangeley Lakes area, because it is incredibly beautiful there. You have great, great dark skies. So I have the sky set here. Hopefully you can all see this for just before sunset. The sunset's tonight just after 8 o'clock. So it's just about setting now. And we're going to put the sun down. So let's let it go down. You see it's quite far north of west, which it is in the summer, though each night is dropping down closer and closer to the west, and it'll set exactly in the west on the fall equinox, which is in late September. But if you do get outside, one thing you want to look for, if it should happen to miraculously clear off, there are a couple planets you can see right after sunset. I'm going to go to about 8:30. Right now on this program, you can see one planet. You can see the moon there, obviously, and the bright star underneath the moon right here is Venus. And it's not going to look quite that bright outside because you have all the glare of the sunset. So while they're going to look really easy to find in here, there will be a challenge to find outdoors. You're going to need a very low western horizon to find these planets, because they're going to be about a half hour after the sun goes down. There's still going to be some sky glow, just like we have here. If you're out tonight, the first thing to look for is that crescent moon, which is very, very pretty. If you have a pair of binoculars, a lot of people don't think about taking out binoculars, but remember, all binoculars are 2 little telescopes strapped together, one for each eyeball. And they usually magnify 7 to 10 times, depending on what you have for binoculars. And the moon is really fun to look at with binoculars, as are the stars, but since we're looking at the moon. So you can see it looks a little hazy. That's because we still have a little sky glow. We're going to look at it again in just a minute after we go a little bit later in the evening, and you'll see the contrast pops out. I did do a star party last night in Surrey, which is near Ellsworth in Acadia National Park. We're right on the bay down there near Blue Hill Bay, and it was a beautiful sky. And we watched the moon. At first, it was very hazy like this, and as it got a little darker, it just seemed to pop out. And so it's a beautiful thing to look at. We're going to look at it again one more time in just a moment or two. But if you wait till it's darker so the moon shows up better, you're going to lose the planets. And these planets, Venus, you'll find pretty easily. It's fairly bright if you have a low horizon. You see it's right down near the horizon. And if you've got a lot of trees around you, it's probably going to be in the trees. But so find Venus first. If you have those binoculars and look at it carefully, you'll notice it's a crescent as well. Anything between us and the sun will have part of the nighttime side facing us. That's what, when the moon looks like a crescent, unlike the movie thing where they have a little boy fishing off the crescent moon, you can't really do that. The moon's always round like a ball. The part you can't see is just part of the nighttime side, so it's darker. Same thing's true of Venus. We got a little bit of the sunlit side shining here on the right, and then you can just barely make out the crescent, the dark side here. When you look at it outside, you're not going to see this part. It's not going to show up. The sky is too bright. But you will see this little crescent. Even with binoculars, if you can really steady yourself, you can see a little tiny crescent. With the binoculars, it's going to be magnified about like that. just a little crescent. If you got a telescope, then you can make it show up a little bit better, more like this right here. And Venus will look softer than the moon because Venus is covered with an atmosphere. Venus has 90 times more air than the Earth and is totally engulfed in clouds, and clouds give it that softness. So it does go through phases, though from the Earth, you'll never see a full Venus, because to see a full Venus, you have to be between Venus and the sun, and Earth never goes there, thankfully. So that's the easy one, because that's the bright one. When you find Venus, let's back off here again, you've got a couple challenges. And the first one you want to look for is just to the north or just to the right of Venus. This one right here is the planet Mercury. Now, Mercury is somewhat bright, not as bright as Venus, but it's of the three planets we can see right now. I know we haven't got the third one yet, but we'll get there. It's the second brightest. The challenge is that it's really low on the horizon, right near where that sun is just below the horizon. So it's right in the glare of the sun. You're probably not going to see it with just your eyes, unless you get just perfect conditions. But if you have a pair of binoculars, look at Venus, get it centered, and think of the round field of view of the binoculars like the face of a clock with, 12 at the top, 6 at the bottom, and then 9 and 3. So what you do is you look at Venus, then you put it over at 9 o'clock. And if there's a little star there, you just keep hopping off to the right. And you might, if you're lucky, you'll find Mercury right here. Now, Mercury will go through phases too, but it's so far away and it's so small. It's like the size of our moon. And you're not going to really see much with binoculars. You won't see any phases at all. Even with a telescope, you won't see too much. But you'll see the dot of the planet. And it's kind of neat to see because it's an elusive planet. It'll be visible for the next couple of weeks. By the middle of August, it'll disappear back into the glare of the sun. Venus is also going to disappear. It's been out all spring and all summer up to this point, but it's going to disappear between us and the sun it's going to be lined up right between us and the sun on August 13th or 14th, something like that. So those are two planets you can find. Venus will be the easiest of those two. Now, the hardest of them is actually higher in the sky. Is this one right here. This is the planet Mars. Now, if you saw Mars last Christmas time, back in December or January, it was as bright as Venus. And clearly right now it's not. Well, Earth goes around the sun and so does Venus, so does Mars. Back in December and January, Earth and Mars were close together in their orbits. And when they're close, it's going to appear brighter. We move faster than Mars. We've pulled very far away from it. And so we're quite a bit farther from Mars right now. That makes it much, much fainter. If you look at with a telescope, you'll see that it's got a reddish orange color. That reddish orange color comes from rust. Mars has rust all through the soil and all through the rocks. Lots of iron there combined with oxygen and creating iron oxide, which we commonly call rust. Now, if you had a really big telescope, you won't see this kind of detail right now because Mars is too far away. The program will do that, but reality won't. But when it's close, you often do see a white patch either on top or bottom. Those are ice caps at the north and south poles. Most of the ice there is not frozen water. There is some, but most of the ice you see on Mars is frozen carbon dioxide. In other words, frozen air. It gets cold enough, the air sublimates into a solid and falls to the ground. So when that, it's going to be like 250, 300 degrees below 0 Fahrenheit to make carbon dioxide do that in a natural setting like this. So I always say when you look at Mars and you think, oh, wouldn't it be cool to be there? It'd be cold to be there, especially if you're near the polar regions. So those are the three planets you can see tonight. You can see Venus, Mars, and Mercury all side by side. The star right above Venus is the star Regulus. That's in Leo the Lion, which you're not going to see because the rest of the stars aren't bright enough to fight through that glare. It's a great constellation to look at in May and June, but by now it's pretty much lost in the sun's glare. So let's let it get a little bit later now that we visited our planets. And if we let the sun and Venus go down, not quite that fast, let's go a little slower. Venus is down and Mars is down, but let's stop just before the moon sets. See how much darker the sky has got now because we've moved that much more away from the sun. And I wanted to take one more quick look at the moon to show you the difference, to get rid of all, just before it totally disappears, take one last look at it. And it'll look much crisper, as you can see here, because we've lost that glare of the atmosphere from the sun shining through the atmosphere. And the contrast is much higher now. You can see craters, all these little circles are craters, and they're made by impacts and rocks pounded the moon. The big dark spots you're all familiar with, which we can't see many of them, just this one right here, are the seas on the moon. Now, there's no water there. These are actually, and they're not craters, they're created by lava flows. Millions of years ago, volcanoes erupted. In some cases, this one was from an impact, but the impact was so deep that magma, it went right through the outer layers of the surface down to the magma below the surface, and the magma filled the crater with lava. But most of the areas are just low regions that filled up with lava from volcanic eruptions on the moon. And so you can see those dark areas. And lava tends to harden. If you've ever been to Hawaii or someplace where there are volcanoes, you know that lava is a dark black colored rock very often. That's why those regions look dark. And right now you can see this one. This is the Sea of Crisis. And it's a nice round one on the limb of the moon. So it's fun to look. Oh, one more thing to do if you do go out with the moon, look at the moon with your binoculars or your telescope. The place you always want going to see the most interesting thing will be right along the line between daytime and nighttime. That's where shadows are longest, and it gives the contrast. It makes the mountains and the craters show up a whole lot better. So that's going to be in the west in the early evening. I always like to start my viewing in the west because anything that's low in the west isn't going to be there very long. The Earth is turning day and night, and just as the sun goes down, the stars set at the same speed as the sun. So you really want to check those things out because within an hour, most of the things that are down low will set and they're gone for the evening. Now, once you've viewed those planets and it's got a little darker, I want you to just look higher in the west. And I always think it's best to start with something we're familiar with. And if you've done these with me before, or you've been outside yourself, if you don't know anything else, a lot of people know the Big Dipper. And right now, the Big Dipper is about 60 degrees up in the northwestern sky. If you haven't seen it yet, it's right here. We've got 3 stars for a curved handle, and then 4 stars for the pot or the bowl. Now, the Big Dipper technically is not a constellation. It's part of a larger constellation called Ursa Major, which means the Great Bear. And we add these other stars to it to make a bear with his nose out front and some legs coming down here. And the handle becomes the bear's long tail, because you all obviously know bears have long tails, right? Well, they do in the sky, and there are many stories that explains how the bear in the sky got his long tail. And you often, if you find books, especially older books on constellations, you often see pictures of constellations drawn like this rather than with dot-to-dot lines. And I always find that they're beautiful pictures, but it's really hard to go outside and look up at night and try to learn these from seeing pictures like this. Much easier to make it a dot-to-dot picture. So I tend to lean that way because, you can always kind of make a, dot-to-dot animal or dot-to-dot cooking pot if you want to make it the Big Dipper. Now, once you find the Big Dipper or Ursa Major, the next thing most people want to find is the Little Dipper. To find the Little Dipper, you go to the back 2 stars of the Dipper's pot. They're called the pointer stars. Their names are Merrick and Doobie. And if you draw a line from Merrick to Doobie and you keep right on going, right up across the sky, the first bright star you come to is probably the most famous star in the entire night sky. It's called the North Star. Its real name is Polaris, but it's commonly called the North Star. And it's not the brightest star. It's somewhere between the 45th and the 50th brightest star, depending on how you split doubles. Lots of stars are double stars, and they look like one, but they're actually 2, or sometimes 3. And so when you count bright stars, do you count those doubles as singles or doubles? Some people do it one way, some people do it another way. So the list varies a little bit, depending on how you count those. Well, it's not the brightest star, but it's famous because if you drew a line from the North Star to the closest place on the horizon, it would take you within a half degree of true north. So you use it like a compass. If you walk towards the North Star, you'll always be walking north. If you walk directly away from it the other way, you'll be going south. So you can use it to help you find your way. If you had a sextant or quadrant, so you can measure angles, and you measure the height of the North Star above the north horizon, in degrees, it'll always equal your latitude. Here in Maine and Rangeley, I know in Rangeley, you're at 45 degrees. You've got that great sign right in downtown there saying you're 45 degrees, halfway between the equator and the North Pole. If you were standing in Rangeley and had a nice horizon and you could measure from the North horizon to Polaris, it would be exactly 45 degrees up. Now, if you're at the North Pole, your latitude is 90 degrees and the North Star is straight up. Measure that angle, it's 90 degrees. It's always equal to your latitude. Kind of cool. It also happens to be the end of the handle of the much fainter Little Dipper. The handle bends like this with a little square right here. And technically that is Ursa Minor, the little bear. Yeah, but you don't add any more stars. You just got to turn that little dipper into a bear and just use your imagination as best you can. Some constellations look like what they're supposed to, and some require more imagination. The big bear, I can kind of see. It's not a great bear, but you can kind of make up an animal at least. Little bear, a little bit more challenging. Let me give you one that's even more challenging, but really fun. If you see how the handle of the Big Dipper curves or arcs, if you follow the arc of the handle, it points you to the brightest star north of the equator, a star named Arcturus, the fourth brightest star in the entire sky. And it's a bright star, and it will have an orangish color, more orange outdoors than it does here. And that's because of its temperature. Colors tell us the temperatures of stars. Orange stars are a little cooler than yellow stars and way cooler than blue stars. So this is a bright orange star, and it's in a constellation called Boötes. Boötes was a man who was a herdsman, and he's also known as the bear chaser. So imagine a shepherd, if you will, and he's chasing the great bear. Remember, we've got a bear over here. He's chasing the great bear away from his herd. So here we have the shepherd chasing the bear. Now, if you look at the lines drawn for Boötes, and you can honestly say that looks like a man, you're doing way better than me. I've never been able to make that into anything reasonably resembling a man. But it's an easy constellation if you forget about the man, just like we forget about the bear and turn it into the Big Dipper. So a lot of us turn Boötes into an ice cream cone. Arcturus is the point. We got a side here. That's draw a line across between those two stars and back down, and that's the cone. And then the circle on top becomes the scoop of ice cream. I usually come out to this star, then up to this one, and I include a couple more here to make it a little more rounded because they're all part of Boötes. So that's Boötes. And if you remember the ice cream cone, that's totally fine. You know, there's no right or wrong way to make these, as long as you use the stars. Officially speaking, everything inside this red polygon is part of Boötes, and astronomers don't care how you connect the dots. Connect them in a way that you can find them and remember them. If you can make a picture and you think it looks like a kite, or you think it looks like an ice cream cone, or you think it looks like the beak of a bird, whatever works for you is totally fine. It's good to know its name. It's good to know where it is in the sky. Good to know how to find it. Use the arc to Arcturus. And the reason you might want to do that is if you get into this and someone says, oh, did you ever see that globular cluster in Boötes? Or there's a comet in Boötes. And you go, oh, I can never find that, man. But you go, oh, that's the ice cream cone. You've narrowed your field of view way down. You're much more likely to find the object you've been talking about. So we have the Big Dipper. Above it, we have the Little Dipper. And then we arc to Arcturus. We find Boötes, the ice cream cone, or the bear chaser. Now, when I show this ice cream cone to kids, one thing they often notice is this little half circle right behind it. They often think it looks like the second scoop of ice cream they just fell off the top. Have you ever had that happen to you? But it's actually another whole constellation. It's called Corona Borealis, which means the northern crown. Don't just go calling it a crown, because there are a bunch of crowns in the sky. This is the northern crown. The brightest star is named Gemma. To me, it looks like a tiara, like a princess might wear. And Gemma seems to be an appropriate name because crowns and tiaras are filled with diamonds and gems. So the brightest star is the brightest gem in the northern crown. Now, to give you an idea, when I say that there are different crowns, let's find another one. Go back to the north. We see that Boötes is off to the west and the Big Dipper is in the northwest. We're going to go to the northeast, just the other side from the Big Dipper past Polaris, and right over here you're going to see a W in the stars. You see it right here? It goes down and up and down and up. This is a constellation a lot of people know as well. It's called Cassiopeia the Queen. And Cassiopeia is always pictured in books as a queen sitting on her throne. You know, it's usually drawn something like this. Again, I have a hard time making a W look like a lady sitting in a chair staring at herself in a mirror. And I teach children. I've been doing that since 1979 in the Planetarium. And the kids and I have come to the conclusion that this is not a queen sitting in a chair. It is Cassiopeia the Queen, but it's actually something she wears. To me, it looks like another crown, a three-pointed crown. And down here, you can draw a little circle, if you will, for where she'd put it on her head. So we call it the Queen's crown. Now, one of the cool things about Cassiopeia is it's right smack in the middle of the northern part of the Milky Way, which is not the brightest part of the Milky Way, but you can just maybe just barely see it here. Now, if you're in Rangeley, and I assume a lot of you are, because that's why you're connected with Rangeley Lakes Heritage Trust, that awesome organization, you've probably noticed the sky is a lot better in Rangeley than if you live in, Needham, Mass or someplace. So this is the sky, probably not of the greater Boston area, but maybe of central Maine. So let me change the sky to the way it might look on a nice clear night in Rangeley, like we're hoping to have tonight. It might look more like this. That's a lot more impressive, isn't it? It can actually make it a little more challenging to learn constellations because you see a lot more stars and they kind of can disappear into the star field. But it's a nice challenge to have a beautiful sky like that. And when it's this bright, you might also notice the Milky Way shows up quite a bit brighter right here. Now, the Milky Way is our galaxy. We live in a galaxy of 300 to 400 billion stars. It's a medium-sized galaxy. There are galaxies 10 times bigger and 10 times smaller. It's not super big or super small. It's kind of average, but it's a pretty nice galaxy because it's home, right? And this is like looking into the thickness of it. What you have to understand is the Milky Way is shaped like a frisbee made of stars. It's round and kind of flat with a little bulge in the middle. And we're inside of it. The sun is one of the stars. Kids often ask me, how far away is the Milky Way? Well, that's like, if you're sitting in your living room, is like, how far away is your house or your camp or your cottage? If you're inside it, can you get closer to it? You can move to a different part, but once you're in it, you're in it. You're in the Milky Way. You can move to a different part, but you can't get closer to this. You can just move to a different spot within it. Even these stars up here are part of the Milky Way, and so are these down here. When you look in this region, you're looking into the thickness. This is like looking out the top, up, and you look at up, look down, you're looking out the bottom. So the stars are all around us. Now, there's only one thing in the sky you can see that's not part of the Milky Way, that is without a telescope. With a telescope, you can see many other galaxies, but with just your eyes, there is one other galaxy. It's the only thing that's not part of the Milky Way, and it's right underneath Cassiopeia, the Queen. So let's zoom in on Cassiopeia. We see her right there. I've kept the lines up. And if you kind of go down underneath her crown and a little bit to the right, you can see what looks like a fuzzy little star right in there. Hopefully you can see that. Let's zoom in closer. Let's imagine you've got your binoculars out. You scan right down here, and you're going to find there's something that looks like maybe it looks like a star that someone tried to erase with a bad eraser, right? Well, that's the Andromeda galaxy. And this is pretty much what it will look like through your binoculars. It's going to look like a smudge of light. It'll have a slightly oval shape to it. You won't see individual stars. You need a big telescope to see that. You'll just see the smudge of light. And if you're in a nice dark spot, like you all will be when you get a nice clear night up in Rangeley, then if you look in the right spot, you can see this with your eyes. And that's the most distant thing you can see without a telescope. It's 2,500,000 light years away. That means it took the light 2,500,000 years to get to your eye. So you're not seeing it the way it actually is today. You're seeing it the way it looked over 2 million years ago. If there's someone on a star, on a planet going around a star in the Andromeda galaxy, sitting around their lake, enjoying their summer, and they look up and they see the Milky Way would look very much like this. And if they had, this ultimate technology, because, aliens in science fiction always have better technology than us. So let's say they have a telescope that's so powerful they can see people walking around on the earth. Can't imagine that's real, but let's pretend it is. They couldn't see you. What they would be seeing when they looked at the earth is they might see cavemen and cavewomen. They wouldn't see dinosaurs. Dinosaurs died 65 million years ago, but they would have seen people living on the earth as people lived 2,500,000 years ago. Interesting stuff to think about, isn't it? Now, if you do have a telescope, it's going to look way better than this. With a telescope, it's going to look like this. Now, with a backyard telescope, you can see a lot of the structure, but you won't see the color. Our eyes aren't very good at seeing faint color. The color is really there. It shows up best with photography. Cameras they pick up the color our eyes can't see. They'll take a picture, then you look at the picture and you can see the color. With their eyes, it's all going to look like grayscale, like you had an old-fashioned black and white TV set. You can see a lot of really cool detail, but the color doesn't work with our eyes. The only place you often see color through a telescope is with individual stars. Stars with their intense light, so therefore the light can affect the part of our eyes that sees color. But the Andromeda Galaxy is a beautiful spot, and that's very much what the Milky Way would look like if we moved far away from it. So now I'd like to follow this Milky Way all the way across the sky, go all the way down to the south. Because remember I said there were a couple crowns, and we've seen two of them. We saw the Northern Crown, and we saw Cassiopeia, which I kind of have nicknamed the Queen's Crown. Well, if there's a Northern Crown, that kind of infers there must be a Southern Crown, right? If you go right down to the bottom of the Milky Way, remember what the Northern Crown looked like, a little half circle. You might look at this one right here. That makes a nice half circle, but that's not the crown. That's the tail of the scorpion, which we'll look at in a moment. The Southern Crown is really hard to see from Maine because it's half below the horizon, half above the horizon. It's right here, this little half circle right here. And it dips below the horizon like this. So this is the Southern Crown. You can put some lines on it if you want to. They make it go around like this. If we could imagine you're floating in space, take the ground away, you'll see the whole thing. It's right here. If you want to know the boundaries, it's just that little box. Actually, everything inside that box is considered the Southern Crown. Though when it was drawn in historical times before the International Astronomical Union divided the sky up into squares and polygons, it was always drawn as just that little arc of stars right there. And it's called Corona Australis, which means the Southern Crown, whereas the Northern Crown's Corona Borealis, which means the Northern Crown. Well, I don't want to leave you floating in mid-space. Let's bring the ground back. Now, right beside that Southern Crown, which you're unlikely to see because you can see the stars are very faint and it's low near the horizon. And remember, in the summertime when it's visible, and it's only visible like right now in late July and early August, we often have humidity like we had last week, and that kind of washes everything out. And if we take away the lines, you can see it kind of just disappears, which is pretty common for Maine this time of year. I'm going to keep us back in Rangeley, though. We've got nice dark skies. Let's come over to this other half circle, and we're going to extend it all the way up through this bright red star named Antares, out to this star, and this is Scorpius the Scorpion. People often call him Scorpio, like they do in horoscopes, but the constellation technically is called Scorpius. And the way I draw Scorpius is this is his head with a claw here and a claw there. So he's got an arm over here. And sometimes I'll draw this little triangle as a claw because I want him to have a little claw. So you could do that. Come over here and I draw this triangle as the other claw. And then we come back to the head. The body comes down to Antares, the red star. And that we often refer to as the heart of the scorpion, because we always think of hearts as red. So that's definitely a red star. Then you come all the way down and the tail curls right along the horizon. And here in Maine, if you're near on the ocean, sometimes you can see those three stars. I was in Surrey last night and we had an ocean horizon. And I couldn't see this one, but I did see these two. So that was pretty good. Then it curls back around to the bright star Shula, which means stinger. And that's the scorpion's tail, his stinger at the tip of his tail right there. So there's the scorpion. They draw them a little differently than I do. They draw, oops, I hit the wrong button here. We don't need the name. They draw the claws coming from the heart. And I usually draw the claws coming from out of the side of the head. You can do it either way. If you find 2 or 3 different apps, you'll find they draw it 2 or 3 different ways. But it's all Scorpius the Scorpion. And I think it kind of looks like a scorpion. You can kind of imagine that, if you will. And you can look at the nice, pretty pictures like that. I like to just use my imagination, though. In ancient times, they used to give him bigger claws. The claws used to come all the way out to this star, and this one came all the way out to this star. Today, these 2 stars aren't even part of the scorpion anymore. They're part of Libra, the scales. But you can tell if you look into the origins of the names of the stars that they were part of the scorpion. These 2 stars have cool names. This star's name is Zubinel-Schmali. Yeah, that's right, Zubinel-Schmali. And this one is even cooler. It's called Zubinel-Janubi. And Zubinel-Schmali means the northern claw, while Zubinel-Janubi means the southern claw. So they were originally the claws of the scorpion. Now, the red star Antares is a fascinating star because that is a red supergiant. And when I say supergiant, to give you an idea of how big it is, Think about the sun. We didn't talk about the sun today. We often do, but I decided just to go into the night sky because of those planets. The sun is 1,000,000 times bigger than the Earth. So it's pretty big. Imagine if you shrunk the sun down till it was the size of a beach ball, maybe 1.5 feet, 2 feet in diameter. If that's the size of the sun and you bring Antares over, Antares would be a beach ball 1/4 mile in diameter. It's a giant star. And it's an old star that may die. You may have heard about Betelgeuse, the red star in Orion, a wintertime star that's been changing its brightness lately. It's an old star too, another supergiant of similar size, and these stars are old and dying, and they may have died. Now, sometimes you hear people say, well, some of those stars aren't even there anymore. Most of them are. Stars last for billions of years. And if a star is only 100 light years away and it's only halfway through its life, it's still there. But these two stars, this one and Betelgeuse in the wintertime, are near the ends of their life. And when they do, and they're going to both explode when they die in supernovas. And when it explodes, we won't know it until 800 years later, because they're both about 700 to 800 light years away. So if it exploded right now, no one on the Earth will know it happened until about 800 years from now. But if it happened to explode 800 years ago tonight, you might be outside looking and suddenly that star will just brighten up. And when stars like that explode, in that moment of the first second of the explosion, that one star will give off more energy than all the rest of the stars in the sky at the same time. That's how powerful the explosion is. And when that happens, it creates everything heavier than iron. Stars create all the elements lighter than iron, but when a star explodes, that's the only way we get things heavier than iron. And what I mean by that is things like gold and silver and platinum, uranium, plutonium, anything heavier and denser than iron. So if you have a gold wedding band on right now, or earrings made of silver or gold, you have pieces of supernova on your body. Kind of cool to think about. Now, right behind this Scorpion is one of my favorite summertime constellations. It's called Sagittarius. And Sagittarius was a centaur. Now, if you remember your mythology, you know a centaur is supposed to be half man, half horse. And as if that's not more complicated enough, this one's also shooting a bow and arrow at the same time. So look at the stars in front of you and see if you can see that. I can't. But there's another way to see Sagittarius, just like we didn't see the bear, we saw it as the Big Dipper. And then we saw the ice cream cone. If you haven't got the idea yet, astronomers think about their stomachs and eating and drinking a lot, because this is often drawn as a teapot. So we have the base of the teapot, a side with a spout, a side over here with a handle, then a lid on top. So that's Sagittarius, the teapot. And you'll see that listed in books, just like you'll see the Big Dipper listed in books. So it is Sagittarius, but it looks much more like a teapot than that's a centaur shooting a bow and arrow. Now, once you find this teapot, look right above the spout. You see a whole bunch of stars here. We're right in the midst of the center of our Milky Way. So there are lots of stars. Beautiful place to look with your binoculars. But you're going to notice this little red patch right here. Now, if you look with your binoculars, you'll see this patch of light. And you'll see even better with the telescope. You will not see the red color. It is red. If you take a picture, it'll come out red. But with your eyes, it's going to look like it's in black and white. It'll look like grayscale. This is a nebula. This one's called the Lagoon Nebula, and it's really always worth looking at. It looks like this up close. If you take a picture, you'll see all this red color. With your eyes, as I said, it's going to look black and white. All these stars in front of it, those are all young stars. So this is a cloud of hydrogen. The stars are all made of hydrogen. So this is a place where stars are being born. There's enough hydrogen here to make 400 or 500 stars like our sun, maybe even more than that. This thing's quite large, light years across, like 40, 50 light years across. And gravity is condensing it down, pulling it into clumps. And so you get these clumps of hydrogen. Once you get a clump, you get a little more gravity, so you pull more hydrogen in. And once you get enough hydrogen in one of these clumps, and there's enough pressure builds up in the core of the clump, that fusion happens. The hydrogen gets squeezed together and fuses and turns into helium. That's nuclear fusion. And that's what happens in the core of stars. It's the same thing that happens inside a hydrogen bomb. And that's what makes stars shine. These are young stars, less than 100 million years old. For a star, that's kind of like being in 6th grade or something, 6th or 7th grade. They're middle school kids. So these are young stars. Stars last for billions of years. So being 100 million years old is still very young. Slowly over time, this whole cloud is going to disappear and will be replaced by a cluster of maybe 300 or 400 young stars. The cluster's already starting to form right here. So that's the Lagoon Nebula. And that red color comes from those young stars of ultraviolet light, and it excites the hydrogen gas around them. And when hydrogen gets excited, it glows with a red light. So this is hydrogen that's actually glowing. Now, right above it is a smaller little cluster, which is one of my favorite ones right here. It's called the Trifid Nebula. And this one, you see some blue color. Now, again, with your eyes, you won't see the colors, but take a photograph and it shows right up. The red is just like before. It's hydrogen gas that's glowing. The blue is hydrogen gas too, but the young hot stars aren't as close by, and there's not enough energy coming from them to excite the molecules to make them glow. But there is light shining on the molecules, and they're simply reflecting light. So the red is called an emission nebula because the gas is emitting that red light. The blue is called a reflection nebula because the gas is not glowing, it's just being lit up by the nearby stars. There are three kinds of nebula here: the emission nebula, the reflection nebula. Let's stop it from drifting there. And then you see the dark lanes going through here. Those are dark clouds of dust, and they're absorbing the light. There's glowing nebula behind it, but they're blocking the light. And those are called absorption nebulas. So the Trifid shows you all three types. And I think it's quite a beautiful thing, especially when you take a picture of it photographically. So they are both right there above the teapot, pretty easy to find. Now, if you look below the teapot right here, you can see a whole bunch of little stars all clumped together. This is one of those open clusters. Just like what I said that the Lagoon and the Trifid will slowly turn into, they're going to turn into a bunch of young stars. This one's called Ptolemy's cluster because Ptolemy, 2,000 years ago, let's leave it like this. That's better, I guess. Some of these have pictures that are better and some are worse. You can just barely see this with your eyes. It's a very pretty sight with binoculars, prettier than it looks here in this image, I think, when you look at the binoculars, because it looks like a little pile of diamonds. Very, very pretty to look at. So that's right underneath the teapot right here. And I think, as I remember, there's about 150 stars in this cluster. And these are called open clusters. And open clusters always have young stars, 100 to 300 million years old. And if you'd been around 300 million years ago, none of these would have been here. But what would have been in their place would be a nebula like we saw with the Lagoon and the Trifid. So we're starting to see the life cycle of stars here. Now go back to Sagittarius one more time. Go to the very tip top of the tea kettle's cover right here, the lid. And if you look just off to the left here, right here, at sight, you'll see with your binoculars, it's going to look like a fuzzy round star. If you look at it with a telescope, you'll see it's another cluster, but this is a different kind of cluster. This one is called a globular cluster. And these are very old stars, and there are lots of them. There are about 500,000 stars in this one cluster. So we have two kinds of clusters in the night sky: open clusters, which are always young stars, and then globular clusters, which are very old stars, billions of years old. And globular clusters halo the galaxy. They're all around the outside edges. And there are several, like 300 or 400 of these around the Milky Way. And we see them around other galaxies too. And they're not totally sure how they form, but they are pretty common. They can have anywhere from 400,000 to 1 million stars. This one has about 500,000, 500,000 stars. And they look like a little pile of diamonds or a little pile of salt or sugar in the sky. Very pretty. We looked at this one last night through the telescope, and you could see all the little individual stars. You don't see the color again, but you see all that texture, and it's very, very cool to look at. So those are both right there near Sagittarius, the teapot. So if you can go outside, look down low, you might find that scorpion first, find Antares, find the curl of the tail, look off to the left or to the east, and you'll find the teapot right there. And these other darker blue lines are how they're trying to draw this centaur shooting his bow and arrow. I think it's a lot of wishful thinking myself, but I try not to be too hard-nosed about the whole thing. All right, so we see a couple things at the bottom of the Milky Way. Let's finish up by looking right up overhead here. If you look almost straight up in the summer sky, there are three bright stars that show up first. If we bring up the haze a little bit, they stand out a little better. That's Vega, Deneb, and Altair. That's the summer triangle. The three of them plus Arcturus, which was in the ice cream cone, remember, are the first stars to come out in the summertime. Venus might come out sooner, but that's not a star, remember. So Vega is the brightest of these three, and then Deneb and Altair. Now, that's not a constellation. It's what we call an asterism. It's simply a group of stars that's easy to recognize. Each one of these stars is in its own constellation. So let's do, I'm not going to do all three because some constellations look good and some don't. The one that looks the best here, it actually looks like what it's supposed to, is Cygnus the Swan. And that's starting with Deneb. Deneb is an Arabic word which means tail. So that's the swan's tail. The body comes up to this star right here. And let's put some lines here. It might make it a little easier to describe to you. So here's his tail. His body is between these stars, and this is the shoulder of the swan. You got a wing out here, all the way out to here. I usually draw a line back to the tail and fill that wing in. They don't here, but sometimes you see it drawn that way. That's the way I envision it myself. The other wing comes way down here. Then I draw a line back to the tail for that. So give him two big wings, then a long neck with a head right here, a star named Alberio. And he's flying right down the middle of the Milky Way. The swan is also known as the Northern Cross. And this is the upright part of the cross here. And for the cross, we just draw from this star to this one. And it makes a nice Christian cross in the sky. Now, the summer triangle and Cygnus the Swan become visible in late June, early July, and stay visible all summer and all fall till right after Thanksgiving. And then it starts to disappear between Thanksgiving and Christmas. The last constellation you see of the three is the Swan. And at Christmas time, it's standing on its head, or the cross is planted in the ground on the western horizon. But right now, you're going to see it high in the southeastern sky, right almost directly overhead, flying right down the middle of the Milky Way. So that's the Swan. Now, what I like to do is to look underneath the Swan. I guess maybe I will show you one more. I'm going to show you the way you're going to have to bear with me on this one a little bit. This is Aquila the eagle. Now, I don't draw it the way everyone else draws it. Everyone else draws it as a bird flying kind of like this. And I guess that works. I have a hard time seeing that as an eagle. So this is Aquila the eagle, but remember, really it's just everything inside that red polygon. So I'm going to show it to you now the way I do it. I can't draw the lines. You're just going to have to bear with me for a moment. So I see an eagle perched on the branch. You know how you see an eagle sitting in a pine tree and they sit there and look around watching for a fish or something? So let's give him a branch to hang on to. I draw a line from this star to this one, to this one, to this one. Those four stars are the branch he's sitting on. Let me get rid of the little dot there. There we go. So there's the branch. The two middle stars, this one and this one, are his two talons or claws grabbing the branch. So he's got a foot here and a foot there. So here's his branch and his 2 feet. This oval right here is his body with a tail dipping below the branch here. Those are his shoulders. And then we've got a nice triangle for his head. You could pretend to color that triangle white so you have a nice bald eagle. And then the bright star Altair is his beak on the side of his head. He's looking off to the side. I wish I could get this program so I could draw the lines the way I draw it, because I can actually visualize that really well. Maybe I've been doing it too long. Who knows? You can see it any way you want, but that's the way I see it. And when I go outdoors, that's the way I tend to point it out to people with my pointer outdoors in the night sky. And you notice this eagle, if you can see the way I am seeing him sitting on the pine tree, you notice he's looking off to the left. He's looking over at this little clump of stars right here, which is another constellation called Delphinus the dolphin. And it makes a nice little dolphin. The little diamond shape here is, let me get that out of the way. That's his body with his nose on front and a fin on top and a fin on the bottom. Then the tail comes down to this star. I usually have it come down to this star too and make a little triangle for a tail. Looks like he just jumped out of the water, made a splash. So the eagle's sitting on his perch, turns his head and looks to the dolphin that just jumped out of the water. Maybe jumped out of the Milky Way. Who knows? Meanwhile, while they're busy interacting, Overhead, of course, we have Cygnus, the swan, flying above the eagle and the dolphin. So a nice little nature scene there in a summer sky. Now, if we stay up a little bit later, I have the sky set right now for about 9:30. That's how late we've gone. But if you're willing to stay up late, there are a couple other cool things to see. Around 11, between 11 and 11:30, another planet comes up. And this planet's worth staying up for if you have a telescope. So here we are. We're at 11:30 right now. And this bright star just came up low in the southeast, and that turns out to be the planet Saturn. And Saturn is my favorite planet to view with a telescope because those rings are pretty special to see. Now, with your eyes alone, it's just going to look like a mediumly bright, slightly yellowish colored star in the southeast when it comes up. If you're here for the summer, right now it's 11:30 when it comes up. By the end of August, it'll be up as soon as it gets dark. So in another 2 or 3 weeks, it'll be up by, in 2 weeks from now, it'll be up by 10:30. And in 3 weeks, it'll be up by 9, almost as soon as it gets dark. So it's each night it comes a couple minutes earlier than it did the night before. Now, with your binoculars, you won't see the rings. It might look like an oval-shaped star with the binoculars. But if you have a telescope to see the rings of Saturn, it'll look something like this. The thing you'll notice, last night at the star party, a woman said that, we went and bought a telescope and we looked at Saturn and it's so small. And she was very disappointed. And I said, yeah, but wasn't it like, she said, yeah, it was very sharp, but it was small, not like the big pictures in magazines. We have to remember the pictures in magazines and what we see on the TV and on the internet are mainly pictures taken by space probes that actually went to Saturn, the Cassini probe or the Voyager probes, and they got great up close pictures. With the backyard telescope, at best, it's going to look about like this. Now, with this program, I can zoom in a lot closer. You won't see it this big in your eyepiece. It won't fill the eyepiece, but you'll still be amazed how much detail you can see. What you should know about Saturn when you're looking at it is that Saturn itself, the planet inside the rings, is 700 times bigger than the Earth. It's the second largest planet. The only one bigger is Jupiter. Saturn has no ground. We're never going to land rovers and drive them around on Saturn like we're doing on Mars. No astronauts will land on Saturn. It's clouds and gases and liquids inside. And the winds blow on Saturn at hundreds of miles an hour. It'll be a wild ride to fly into that planet. The rings are made of ice, mostly water ice. So if you took a chunk of Saturn's rings and melted it, I guess you could drink it. I would want to check it out. There might be something mixed in with that. Who knows? But it's mostly water ice. But it's not frozen. It's frozen solid, in little chunks. It's not like the frozen Rangeley Lake in the wintertime. It's not a sheet of ice. It's more like the crushed ice you put in your soft drink, only there's no soft drink. Lots of little particles, all floating separately like an asteroid field. From the inside edge to the outside edge, from here to there, that's pushing 30,000 miles. It's a lot of crushed ice. Top to bottom, though, if you measure the thickness, some places it gets to be a mile thick, but in most places it's less than 100 yards thick. 100 yards, think about that. If you tip Saturn up on edge and brought the rings down on the 50-yard line of the Super Bowl, the rings would fit between the goalposts, but they'd extend 30,000 miles into the sky. Wouldn't that be a halftime show, huh? Kind of cool to think about. It'd actually be very cold because they're frozen to 300 degrees below zero. You wouldn't want to be anywhere near them. You'd be frozen solid yourself, but just an interesting thing to perceive its size and what you're looking at when you view this planet. Considering it's 1 billion miles away, it's amazing that we see it with the clarity we do. So there's Saturn coming up right now around between 11 and 11:30. And this evening or tomorrow night or next week. Each night's a little bit earlier. All right. And the last thing I'd like to talk about is something that you're going to start to see happening in the sky, and it's going to peak on the night of the 12th and 13th of August. I can't make it happen here, but that is the Perseid meteor shower. Now, I know a lot of you probably have seen the Perseids before. They happen every year on the 12th, 13th of August. They actually start happening right now. If you went out tonight, you might see a few more meteors than normal. On a normal night with no meteor shower, you might see 2, maybe 3 in an hour. For the next couple of weeks, you might see anywhere from 5 to 10 in an hour. When you get towards the peak, which is, it kind of goes in an arc, and the peak is on the night of August 12th in the morning, the best peak is going to be the morning of the 13th. You might see 100 to 120 in an hour. So a lot more meteors on that night if it's clear. And luckily this year on the Perseid meteor shower, we're not going to have any moon in the sky. You might have a little waning crescent in the early morning hours, and that's it. So the moon is a problem because when the moon is out and it's bright, it washes out the stars. The sky doesn't look like this. It looks more like this, only it's glowing more, almost like that sunset. And then meteors can be very faint. So it helps to have a dark sky to see lots of meteors. This is going to be a great year if we can get a clear night, which has been, pretty precious this summer. But we're due for a few. So I'm hoping we're going to get a clear night on the night of the 12th and 13th. But even for a few days before and a few days after, you'll see a lot more meteors than you see on the normal night any other day of the year. The Perseids are not the biggest meteor shower of the year, but they're the most observed. The biggest meteor shower is the Geminids, which happened in December. That one easily has 120 to 140 meters an hour. But the problem is when it's clear and those beautiful nights in December, it tends to also be very cold, and most people don't want to go out and lie in the snow and look at meteors for an hour or two. Some of us do, but it's much more comfortable in August. The mosquitoes are down, hopefully by then, and it's warm and you're on vacation. Get out and see the meteors. And they're called the Perseids because they seem to radiate from the constellation of Perseus, which we see. I'm sorry, hit the right button right there. Doesn't look like much. It's just kind of a V in the sky. It's right under Cassiopeia the Queen. So remember, we came down here and saw the Andromeda galaxy, which you can still see right here. Go down to her left towards the northeast horizon, you're going to see this V shape, and that's Perseus the hero. And that's not where you really want to look to see them. Meteors are coming at us. They're all coming parallel. And it's like being standing in the middle of railroad tracks to go to the horizon. They look like they touch in the distance. They don't touch. It's just our perspective. Well, we're on a moving object called the Earth. We're traveling through space at 167,000 miles, not 167,000 miles an hour, which is fast enough. And when we go through this flow of meteors, we interact with them, we hit them. And some fly to our left and fly to our right because they're coming at us from all over. They're all falling parallel though. So some look like they go this way and that way. But if you follow their tracks back, they'd all point to in this region of the sky. So one of the best places to look, you might see one way over here, but if you see it, it'll go zoom across the sky like this. So whatever direction they're going, if you follow where they came from, you'd find it would point back towards Perseus. See, when here, it might go like this. It might go like that. It might go like this. So trace them all back and they'll point towards Perseus. And you know that that's a Perseid meteor. Now, if you're out there and you've been seeing meteors, you're all really excited, and suddenly you see one that goes like this, that's not pointing back towards Perseus. Well, that's just a regular old meteor. There are meteors every night. That one's not part of the meteor shower. It's an independent meteor that just happened to be here at the same time. This one, if there was no meteor shower, it would just be a rock that we happen to run into as we're going around the sun. So that's coming up on the night of the 12th and 13th. You'll see that's a good night to go observing. And if you really want to see them most, the best time is the 2 hours before sunrise on the 13th. That's because we're looking kind of dead ahead in our orbit, interacting with the most meteors. So that's coming up. And I'll be in Rangeley. I'm planning on clear nights on the 15th, which is just a couple days after the meteor shower. We should still see a bunch of meteors that night. And we're going to be, I believe we're going to be on Quill Hill. I hope that's where we're going to be. And we're going to have a beautiful night and get to see all this stuff for real. So I hope you're able to join us, and wherever hopefully it's Quill Hill, but if it's not, we'll be someplace else. We've done a number of different locations in the Rangeley area, and the sky's beautiful wherever we happen to be. So I'm hoping you'll all join us there, and keep our fingers crossed that we get a clear sky. I hope you've enjoyed the tour this evening. It's been great fun sharing the night sky with you, and I look forward to meeting some of you in person in another 2 or 3 weeks. If anyone has any questions, I'll be glad to take those. You can either unmute and ask, or you can type it in the chat and Sarah can ask me. Otherwise, I think I'm going to stop sharing. We can always go back if someone has a question. Thank you, Sarah.
Thanks, John. So thank you everyone for joining us. And again, thank you, John, for hosting. So we have 2 other night skies events coming up. So we have one, like John was mentioning, on August 15th. It is up at Quill Hill. So it's really important that if you're trying to join us, that you register online beforehand. I know it's a little bit different than we've done in the past, because in the past we've been at EcoVenture, and so if you kind of showed up, it's not been a huge deal. But we are turning people away if you show up that night and you don't have a ticket. So please, please, please make sure that you pre-register, so that we make sure that you are able to join us. Like I said, we're all crossing our fingers, hoping that it'll be a nice night for us. But so we have that, and then we also have one in September, which I think is September 12th. Then of course we'll probably be doing stuff in the winter again with the snowshoe hikes, and as long as the weather wants to cooperate with us, and we'll celebrate International Dark Skies Week next year. There's supposed to be a total solar eclipse that we can see from Rangeley, and that's the first day of International Dark Skies Week. So we will have a great way to kick that off with that celebration. But otherwise, if you guys have questions or anything, feel free to reach out to us on Facebook, or right through our website at rlht.org, and you can learn about other upcoming programs. Have a good night, everyone.
Thank you, Sarah. Thanks everyone for coming. Hope to see you in another couple of weeks. Bye-bye.